Okay, so in the previous video, we saw how we can write the Newton's equations of motion in rectangular frame. But depending on the problem, it may not be the best or the most efficient way to solve a problem. For instance, if we know a lot of information about the path of a particle, as we saw, to write the kinematics, maybe a frame that is tangential and normal to the path could be better. Similarly, if you want to write the equations of motion in such cases, probably you want to go with a tangential and normal frame. So just to refresh your memories, we have two axes, one tangent to the path, another one normal to the path toward the center of curvature of the path. And if you have some random force, arbitrary force acting on it, acting on a particle, you can create, maybe go with green, create or find the two components of the force along this axis, and your vector equation can become, or you can decompose it into the two axes. Sum of forces, all forces in the tangential direction becomes mass times tangential acceleration, which previously we saw is mass times, v dot. And sum of forces, all forces, their normal component is mass times the normal component of acceleration, which we saw was v squared over rho, the radius of curvature. So depending on how much information and what information you have available in your problem, you may want to forget about rectangular frame and go with a normal tangential frame. And one thing I want to again emphasize here is that at the time we mentioned there is a third axis called, let's call it UB, binormal, perpendicular to both UN and UT. And along this direction, we said acceleration is 0. So if you want to be concrete, sum of forces in that third axis is going to be mass times AB equals 0. So you should conclude that any force that is out of this plane made by UT and UN the forces should add up to 0. So I think that is good for here. I don't remember anything else to add. Yeah, I don't remember anything else. So let's call it a video and let's look at polar frame next. So see you then.